All right. Welcome to the next latest and greatest webinar on, looks like CIS-210, Principles of Computer Programming 1. I am Professor Lusby, and I wanted to go over, we're in week 7. We're definitely to the finish line, and I wanted to create another webinar where I go over what it is exactly that we need for week 7. I don't have a lot of time today, so but I did want to provide you some guidance on your weekly assessments. All right, so I'm just going to dive right in here. I assume everybody's familiar with the classroom. I assume everybody knows where the virtual desktop is by now, and these wonderful programming assignment frameworks files. So I'm just going to head down here to week 7, and week 7 is all about chapter 7 of your textbook. Chapter 7 is all about, we've been using classes in the past, these predefined classes that come with the Java JDK or library. But we also need to learn how to create our own custom classes with unique methods, constructors. If we use the principles of encapsulation and make all of our member variables private, we're going to have accessors and mutators, which is what industry expects. And at a high level, that's really what we're focused in on here. There's a lot of good examples in the code. Also, this equals method is important. A lot of you have already found quite a few of those examples, and you're posting about them in the discussion board, and that is really, really good news. So for sure, yeah, we need to be familiar with chapter 7. If we click on this overview and objectives, that'll let us know at a high level what we're trying to do here, right? Introduce user-defined classes and how to implement these custom classes. Yeah, and all right, so high level, that's what's going on there. Then we also have this week 7 supplemental resources. Again, feel free to take a look at that. Some students find it useful, some students find it confusing, but at the end of the day, always come back to the textbook. All right, and so then we get into what it is that we need to complete for graded activities this week, and there's 3 of them, so a little bit lighter than week 6. We have a discussion forum, as always. All right, we're going to take a look at that in a second. A programming assignment, and of course the weekly quiz. All right, so what do we need to do here for the discussion? The discussion for this week wants us to look at Chapter 7, Programming Activity 2, Writing a Class Definition. All right, so if we open our book and we go down here to Programming Activity 2, we are going to see that they created this airport, let's call it an airport simulator or airport database simulator, where, yeah, it's a pre-written client program that instantiates several airport objects. And then it basically, you load some data into the airport objects and you compare some of these airport objects. And each airport object basically has 2 pieces of information, an airport code and how many gates that particular airport has. And so, but notice that they want us to complete this airport class. There's a lot of missing pieces, right? They want us to declare another class variable that meets this criteria. They want us to create a default constructor. They want us to create an overloaded constructor, at least finish it, because it does look like they are defining it. But they want us to add some additional code there. Same here. Get airport code. Remember that with encapsulation, our member variables are private, right? And since these member variables are private, we can't access them outside of this class, and we need to create what's called accessors and mutators. And so for the airport code and the gates, we create an accessor called get airport code and get gates that does nothing more than return whatever is inside of each one of these member variables. All right. Um, and it looks like it did a lot of that for us already. Okay, so they wrote the accessors for us. They want us to modify this method. And then down here, it's called the mutator methods, the set methods. Looks like they wrote the set method here for us. Looks like they wrote the set method here for us as well. And notice this is kind of the beauty of encapsulation and using accessors and mutators is that when we pass a value in that we want the airport um, object, give me just a second. Yeah, when you pass that parameter in, we can actually add logic, right, to do input validation on whatever it is that's being passed in because it doesn't make sense, right? If they pass in a negative number for gates, well, we shouldn't set the airport's gates information to a negative number so we can check, well, is gates greater than or equal to 0? So this is another advantage to using accessors and mutators is that uh, we can use them to validate our data, uh, at least the data passed in, before we set our actual member variables equal to whatever those values are. So another really important aspect of encapsulation is it allows us to do input validation with the mutators. Um, and then step 5 says, okay, let's create a toString method. Um, and this is useful when you go to print a specific object that you created. If you print it without this toString method, you're just going to get a memory location. It's going to let you know where that object exists in memory, but that's as descriptive as it is. It's not very useful. If we create a toString method, then then we're able to actually return what uh, the values inside of the class are instead of just a memory location. So we could actually return a string that contains, let's say, the airport code and the gates instead of just a memory location. So the toString method, definitely in industry, uh, you almost always want to have a toString method for every custom class that you create, just in case you need to print it out to the screen. You know, you want a nice user-friendly string that represents that object and not just a memory location. So they want us to create a toString method. And then finally, uh, an equals method, because a lot of times what we want to do is compare two of these objects, right? If we have two airport objects, um, maybe it's referencing the same airport. Maybe they both have the same airport code. Maybe they both have the same number of gates, and maybe they don't. But at the end of the day, we need some way of comparing these two objects because they're not just numeric values, right? It's easy to compare an int with an int or an integer with an integer. We can just use those relational operators, right? Greater than, less than, or equal. Well, when you go to compare two objects, you can't just say, well, is this object equal to this object? Because they both might have the same information, but they're at different memory locations, and the compiler is always going to say, no, they're not equal because they're at two different memory locations. So this enables us to drill down a little bit further than just memory location and look at, right, is the gates in this object equal to the gates being passed in? Is the airport code, I guess they don't, yeah. If the airport code and the gates in this object is equal to the airport code and gates in the airport object being passed in as a parameter. So a lot of important concepts going on here, very typical for the way we create classes in industry. So this is a really, really good exercise. All right, so how do we go about completing this? Well, we're going to launch our handy dandy remote desktop, right? We're going to go into NetBeans 8.2, and we're going to create a new project like we always do, right? Java application. This is, give it a nice descriptive name. This is week 7 discussion. Bada boom, bada bing. Uncheck this because we have the files we need. We just need to import them. Leave this as is. All right, so this should look like this. Click on finish, and we should have a nice empty project, and we do. Now what we want to do is go into Chrome, log in inside of the virtual desktop. Go into Chrome inside of the virtual desktop, go to the classroom, right? Using this web address, type this web address in, go to the classroom, log in, and here, go down to, where is it? I always forget. I think it's right below the virtual desktop. Here, CIS-210 Programming Assignment Frameworks. Go ahead and download that. Okay, once it's downloaded, go ahead and open it up, and we should see it has everything that we need. So we go to Chapter 7 here, Programming Activity 2, organize them by type, and these are the files that we need to import, all right, for this particular activity. All right, so we're going to minimize this. We have the files we need. We're going to minimize this. Make sure that NetBeans is open on the new solution project that you just created, and then open back up those files in using File Explorer, and then drag and drop. Hold the left mouse button down, release on top of default package, and you should see something that looks like this. Now, a lot of our activities in the past compile out of the box, and you're supposed to go in and add some new functionality, some new code. However, this one here does not. And the reason is that inside of airport drawing, what it's complaining about is that get count airports is not defined. The reason it's not defined is because, remember, this wants us to modify airport.java and add all of these things. And if we look here at airport.java, we'll see that, yeah, none of this is done yet. And that get count airports guy, yeah, is here, and we haven't implemented it yet. So that's why it is definitely, that's why it's freaking out. All right. So we need to complete, or your discussion asks you to complete this, this, and this. Number 1, 2, 3, 4, and 5, and 6. Make an attempt at that, and then write your discussion post based on that. Do you have to find a solution? For at least for me, no. But it is a good exercise. It will prepare you well for industry and your assignment for this week. So yeah, spend some time trying to come up with the solution. But at the end of the day, I do want us to talk about the solution. I did come up with the solution. And so I created this project, did exactly what I showed you, and then filled in the missing pieces. And the missing pieces, at least this is one solution, and they're very particular here in these requirements for this programming activity. I don't know how creative we could really get here, but maybe there are other possible solutions. There's always, 10 different ways to write the same code, but in this case, I'm not sure how many more solutions there are than this, but maybe there's a couple. All right. So for sure, for number 1, add a static class variable called count airports. Well, that's what this is. Notice that all variables are private. That is intentional. We should never expose the variables to outside classes. We keep them internal only. And static just means that no matter how many airport objects we create, there's only going to be one count airports variable under the hood of all these different airport objects. And typically, when you want to do this, create these static variables, is that whenever you have a counting variable where you want to count the number of airports or airport objects created. There are some other instances or nuances where you also want to create static variables, but the most common time you create a static variable is if you want to count the number of objects of that type that's created. All right, so just know that's why we're doing this as a static, is we're trying to create a counter that counts all the airport objects. All right, here is our default constructor. How do we know it's a default constructor? Number 1, it has the same name as the class. right? Class name is airport. The method name is airport. So for sure it's a constructor. How do we know it's a default constructor? Well, because it doesn't have any parameters. There's no information or inputs going into this constructor, no parameters. So because of that, this is known as the default constructor, and its whole purpose is, well, just initialize all the member variables in that class to a blank or well-known value. All right. And so that's what we're doing here. And it tells us we'll set the airport code to an empty string. All right, done. Add one to the count airports, the static guy that we just created. Because we're obviously, if the constructor is being called, we're creating an airport object and we want to increment count airports by one because we just created this particular airport object. All right, so we're going to increment that counter by one. And then here it wants us to create an overloaded constructor. Well, how do we know this is overloaded constructor? Number one, it has the same method name as the class, which is airport. But here's how it's overloaded, is that we're passing in some parameters that will help us initialize the variables. So instead of initializing airport code to, an empty string, maybe we know the airport code when we create this airport object, and we can pass it in using the start airport code parameter, and then we use it here. So we say, okay, well, we've got this airport code member variable, set that equal to whatever this parameter called start airport code, whatever it has inside of it. All right. Same with gates. Well, let's take the number of gates that was passed into this overloaded constructor, and let's call the accessor method. And this is usually the accessor and mutators are used outside of the class. Here, they're being a little cautious and they're also using it inside the class. You could, another solution could be, what is it called? Gates. Yeah, it's just called gates up here. This set gates could also be written like this. So there is another way that we could do this, right? Set gates equals start gates. Um, oh my gosh. Here. All right, gates is equal. Both of these lines do the same thing, but because we're inside the class, we can't access the private member variable. And I would say, yeah, if you're inside the class, you know what you're doing. You should be able to manipulate and touch those member variables. But there are some very cautious programmers, and maybe the programmer who's modifying this doesn't know about, well, gates can't be negative. So yeah, maybe it is more advantageous to call this accessor method here. All right, but either way, we want to set whatever gates is, that member variable up above, equal to whatever that parameter value is passed in called start gates. So we know this is overloaded, same class name, and passing in two values to initialize those member variables. All right, and then here's our accessor methods. How do we know they're accessor methods? Because they have the keyword get in front of them, number one. Number two, they are returning one of the member variables values. So get airport code, guess what it returns? The private airport code. Get gates, guess what it returns? The private gates. All right, so this was already done for us. Get count airports, however, they wanted to see that we could implement at least that one because we created that count airports, that static count airports variable. Notice that if you have a static variable inside of the method, you do need to declare static outside or the compiler, compiler will freak out, usually. Let me see here. Oh yeah, you see, maybe not in this class, but anybody trying to use it, it's going to freak out. A lot of students forget to include the static. Now watch, if I hit save, now it's happy. So make sure that you use static here and you are returning count airports and you should be fine there. All right, next is showing us, well, if we have mutators, how do we know this is a mutator? Well, it has set in front of it. And It's taking whatever is passed in as a parameter, and we're setting our member variable equal to whatever that was passed in as a member variable. Okay. So set airport code. We're setting to this new airport code being passed in. Set gates, same thing. We're passing in new gates, but they did add some validation logic here. Input validation, right? Make sure that new gates is greater than 0. It doesn't make sense to have negative gates at an airport. So again, these mutator methods help us do input validation, and then we can return whatever that. It is interesting that they're returning an airport object for these accessor methods. Um, it's a unique design decision by the author of the book. Um, I've seen other instances because in theory we're just setting the airport code. I'm not sure why we're returning the same airport object. Obviously they have it, or they couldn't call set airport code and they couldn't call set gates. But whatever, that's why it's returning this airport. Another way to do it. I'm not sure that's really necessary. ToString. All right. Well, if we call print in an airport object, well, how can we be more descriptive than just, well, this is where it lives in memory? Well, let's return airport code and the actual gates information. All right, as a string. And Java is smart enough to take this information here, airport code and gates, and convert it to a string and then return it as a string. Okay. What else? What else? What else? What else? Equals. A lot of times we want to compare two objects of the same type, and it's a little bit wonky in that every object in Java inherits from this object base class. Just know that what you have to do, what's important here, is that you have to cast whatever this O object is, you have to cast it to the appropriate class that you're comparing it to. So that down here you can see, well, is this dot gates, right? Is this current object's gates equal to this A object or the object passed in's gates, right? Same here. Is this airport code equal to this A airport objects airport code? And if we had more member variables, well, then we would crank all of them out. And this, all right, that's all I'm going to say about that. This is going a little bit deep into the weeds. We'll talk more about this in CIS-211. All right, but this is the solution to the activity for week 7. And you're going to see that your assignment uses a lot of these elements. That's why I wanted to kind of spend time talking about that. All right. And if we run this, right, once we get it all to compile, once we add all of these elements, once there's no errors over here and we run this, you should see something that looks like, please hold. You should see something that looks like this. And again, this is a weird kind of GUI. There's a test class behind the scenes here executing all sorts of commands and creating airport objects and then calling the different accessor and mutator methods and constructors for the airport objects. And it's trying to show you visually here what's going on, right? Well, I created this airport object called airport 1. I created this airport object called airport 2. They have the same information. So now when I compare them using equals, right, so equals compares the memory location, equals, the equals method compares the contents. All right. So that's what that should look like. It should run, should say actions complete. I think if one of these things was implemented incorrectly, you would see some sort of red writing on the screen and test fail. All right, so uh, that's that. All right, what else? What else do we need to do for week 7? Let's take a gander. Why is it complaining here? Week 7 discussion. Oh, right. That's when we originally imported the files. It's going to freak out because we haven't created that static method yet, wherever that is. This guy here. All right, so enough about that. Let's continue on, shall we? Let's talk about the week 7 programming assignment. So for the week 7 programming assignment, kind of focusing in on, the past 2 applications being NASA applications and looking at the weather data and the temperature and the wind speed. Well, wouldn't it be really cool if we had a weather data class, right, that would store the, let's say, wind speed and temperature. So that's what it's calling out here, is that we should create a class called weather data that has this design. Obviously, the constructor is going to be called weather data because that's the class name. We've got an overloaded constructor where we can pass in, let's say, the temperature and the wind speed. We've got mutators or set methods called set daily temp and set wind speed. We've got accessors or get methods for the daily temp and the wind speed, a string method, and an equals method. And if we implement all of these things correctly, they give us some test code here. We want to create another class called test that contains this test code. And when we run this test code using the appropriate weather data class, we should get data that looks like this. This is how you know that you are done with the assignment. If you run this test code and your output looks like this. There's a couple of minor modifications that I had to make here. Definitely all these quotation marks, if you copy and paste, I'll show you that in a second. All right, so at a high level, let's create a weather data class. Let's test it using this test code. Let's ensure that this is the output. All right, that's what we need. That's what we want to do. All right, how do we go about doing that? Well, I'm glad you asked. Let's go to our virtual desktop. Let's launch NetBeans. Let's create a new project, Java application. Let's give it a nice name. Was this week 7 assignment? Yeah, go ahead and create the main class because we don't have any code. We are starting from scratch here. Okay, give that a nice name here. Leave this unchecked. Leave this as is. Go ahead and click on finish. Okay, so here is our nice, wonderful new project that contains a main method. Everyone should be used to that by now. However, this main method, all right, we're going to need, okay, so this is, the question is, we need 2 classes. We need a weather data class and we need a test class. Create another class called test that contains a main method. So for sure, this is our main method. This needs to be our test class. So what we want to do here is let's rename this, right click, say refactor, say rename. Let's rename this to test. Hit refactor. All right. So we meet the requirements there concerning the main class name. The other thing we need is here, this weather data class. So what we want to do is come over here to the default package, right click, say new Java class, and here is the weather data, the new class name. We click on finish. All right. And yeah, here is our new weather class. Okay, at this point, we're sitting pretty. We have both Java files that we need. We have both classes that we need. Now what the heck do we do? Well, I'm glad you asked. So before the webinar, I did everything I just showed you there, created a new project, added those two classes, made sure the test class had a main method. And let me give you some guidance here. All right, let me point something else out real quick before we go there. This test class, a lot of you are coming here, including me. Here's the code, right? So why not highlight it, hit Control C or copy, and come here into the main method and hit paste. That is definitely what I would do, in industry if somebody gives me code. However, lots of errors here. First of all, it's not indented properly. Okay, so I would strongly suggest, and if you want to indent more than one line at a time, I don't know if you noticed that, you can highlight everything, and if you hit tab, it'll indent all the lines for you. If you hit shift tab, it will unindent. All right, so tab indents, shift tab unindents, whatever is highlighted. All right, so at least, and because I want it indented, because here's main, we need to make sure that all these lines are indented underneath the main to represent scope properly. The other thing that I noticed it took me a while, these quotation marks in the description are not real quotation marks. You need to delete and put a real quotation mark. So even though they look the same, they're not the same. And you want to do that with all of these quotation marks. All right. All of these quotation marks need to be real quotation marks. So you need to find all the quotation marks and replace all of the quotation marks. And originally, the test code had in the classroom look like this. This is a typo. What should be used, because there it's just going to look and see what is the object for day one at the same memory location as the object for day two. If we use the equals, now it's going to compare the contents of day one with the contents of day two. All right. So I updated it in the classroom. You should be good. If you don't see this, if you don't see equals here, please change it to equals and also change all those quotation marks. All right. And at this point, right, we're going to see some errors. And the reason you see errors is because it's trying to use, right, day one, which is weather data, and weather data doesn't have anything in it. So yeah, of course it's gonna freak out. All right. So let me show you some guidance here concerning the week 7 assignment. Let me go and close all this so we don't get confused. I did correct all the quotation marks that I showed you, made sure that the equals was here, but the reason why it's not freaking out here is because inside of weather data, I went in and created all of those methods that, number one, the requirements outline, right? All these guys here, but number two, that test code is looking for. All right, so this is, high level what your weather data class should look like. I haven't completed, right? I haven't put in any of the code inside of any of these methods. I do expect you to be able to do that by this point. And when we get to CIS-210, you're going to have to come up with these method signatures on your own. All right. But here is the default constructor called out in the requirements. Notice there's no parameters. It is named the same as the class. This is the overloaded constructor where we're passing in, we know the daily temp, we know the wind speed. This is the accessor methods, set daily temp, set wind speed, that is supposed to set the current temperature, set the wind speed. These are the mutators, right? Get daily temp, get wind speed, that returns the daily temp and the wind speed. And then here is the equals method where we're supposed to test whatever that object is that we pass in, is its wind speed and daily temp equal to this current object's wind speed and daily temp. And don't forget, yeah, you need to create these private member variables up here at the top. That is very typical in this industry. You want to declare your private member variables at the top of the class before any of these methods. All right. And so if you come in here and fill in, right, you need to fill in all of these methods with the appropriate code, and you run this code here. Do not alter this code. This code needs to remain as is. Okay. Even in industry, when the company has an existing code base, typically they have a lot of automated tests that are already in place, and your code, whatever new code you add, is expected to play nicely, right, with the existing automated tests. And if they want to do regression testing, you can't change the existing test. You can add new functionality, but all the old functionality should work as is. And so that's how we need to treat this as a regression test. Don't change any of this. You're just adding the code in here. And if you run this, eventually you're going to run this. And right now it should fail miserably because we haven't added any of this code. Here it is. Day 1 is not equal to, day 2 is not equal to, day 2 daily temp is 0, day 3 wind speed is 0. Horrible descriptions for the day 1 and day 2 object. What this should look like when you get everything right here is this should look like this. Okay. Eventually, once your output looks like this, then you know you're good. You've met the assignment requirements, and I will issue full credit. All right. Right. So that is the objective. Fill in that weather data class with functionality that will help you get to this output. All right. What else? What else? Last but not least, we do have this wonderful week 7 quiz. I think it's 10 questions again, 25 minutes, 1 attempt. So definitely make sure that you are very comfortable and familiar with Chapter 7 before taking that quiz. All right. So that's basically all the time I have for today. I'm really hoping that that helps give you guys a good, some guidance there on how to complete these assignments. Again, keep providing me feedback. Like the video, send me an email, whatever it is. It's what helps make make these webinars better. I really do appreciate the feedback. Okay, so have a great rest of your day, and let me know if I can help.